We've talked about the word tangent a couple of times this year, and this time, well, last time we talked about it, we were talking about it as a trig function of the acute angle. But this time we're talking about an actual tangent line, which is a line that's going to make contact at a single point. The line actually touches the circle but doesn't actually intersect, which gives us our definition then of a tangent line is a line in the plane of a circle that intersects the circle in exactly one point, and the point of tangency is the actual point of intersection of the tangent line and of the circle. So we have two different theorems that's kind of like the converse. So that theorem 10.9 says that if a line is tangent to a circle, then it's perpendicular to the radius drawn to the point of tangency. So for instance, if we have this circle, and let's say this point is A, and we have a radius going to our point of tangency at B, the theorem says then that our radius is going to be perpendicular to our tangent line. The converse of that is that if a line is perpendicular to the radius of the circle, then the line is an actual tangent. So therefore, since we know that our line is perpendicular, our radius line is perpendicular to the line outside the circle, therefore this theorem tells us that our line is an actual tangent line.
Welcome to a lesson on solving for unknown values using the properties of a tangent to a circle. Let's first review that property. A line is tangent to a circle if and only if the line is perpendicular to the radius drawn to the point of tangency. So if this is a tangent line where B is the point of tangency, radius AB will be perpendicular to line BC. Let's go ahead and take a look at our first example. Here we're given a tangent segment and the radius of the circle drawn to that point of tangency, which we know forms a right angle. So now that we know we have a right triangle here, we can use the Pythagorean theorem to determine the value of x. So we'll use the Pythagorean theorem that states that the sum of the squares of the legs of a right triangle equal to the square of the hypotenuse of the right triangle. So this side is the hypotenuse, therefore has to be C, and we'll let this side be side A, and this side be B. So we'll have x squared plus 20 squared must equal 24 squared. So now we'll go ahead and simplify this and then solve. So we'll have x squared plus 20 squared is 400 equals 24 squared is equal to 576. 24 times 24. So now we'll subtract 400 on both sides. That will be 0, so we'll have x squared equals, this will be 176. Now we'll square root both sides of the equation. Since x is a length, we're only going to have the principal square root, or the positive value. So we have x equals the square root of 176. Now we should try to simplify this. So let's go ahead and see if we can identify any perfect square factors of 176. This number is divisible by 4. 176 is 4 times 44. 4 is equal to 2 times 2, which are both prime. 44 is 4 times 11. 11's prime. And then 4 is again 2 times 2. So if we want to show some work here, we have x equals the square root of, we have 4 factors of 2 and a factor of 11. Every time we have 2 equal factors, we have a perfect square factor. So 2 times 2 is 4, that's a perfect square. 2 times 2 is 4, that's a perfect square. So this pair gives us a 2, this pair gives us a 2. So we have a 4 outside the square root, so 4 times the square root of 11.
Another use that we can use the Pythagorean theorem for is to prove that converse of our theorem, where we know that a line is tangent if it's perpendicular. So let's draw a line and check. If we have a radius to the line of 4, we know that it has to be a perpendicular line and form a right triangle. If we draw another line, say our hypothesis, and that distance is 4. And we also know that the line distance from the right triangle on that side is also a distance of 4. We can use the Pythagorean theorem to prove whether or not this is a tangent line. So since this side is going to be C because it's across from a right angle, we can set up a Pythagorean theorem. So we have 4 squared plus 4 squared is equal to 5 squared. Well, 16 plus 16 is not going to equal 25, so therefore this line cannot be tangent to our circle. Our final theorem tells us that if two segments from the same exterior point are tangent to a circle, then they are congruent. In this example, we have one exterior point here, and we have one line tangent to circle 0, and we have a second line tangent to circle 0. Since both segments are from the same exterior point, then this line segment is going to be congruent to this line segment. This can be helpful when we're trying to find out what some of the different lengths are. For example, we have a line where I have the same exterior point of T, and AT is going to be congruent to TB. That also means that BT is also going to be congruent to TC.